So the last topic we are going to look at in this chapter is subroutine call and return, and connected to that is the idea of interrupts. So interrupt is an important topic which we will be learning again in this course and to some extent in operating systems. We'll be looking at the introduction of what an interrupt is in this lecture, but before that we'll look at subroutine call and return to understand the core idea. So let's say you are executing a C program or a Python program. There are some lines of code, some assignment, declaration, print, input, something, and then you reach a function call. Now so far you've been executing your main function, int main. Suddenly from there you've called another function. So the execution of int main should be paused and the function you called should be executed fully. And once that is completed, the execution of int main should resume from where it paused. And the same thing happens irrespective of how many functions you call. So let's say I'm executing int main and I've finished 5 lines, then I'm calling function 1. So my computer needs to remember that I've finished 5 lines of int main, then it should go to function 1, it should start executing there. And let's say again I've finished 7 lines of function 1 and inside function 1 I'm calling function 2. So this 7 lines should also be remembered and then it goes to function 2. It executes there. Once it finishes that, it should come back to the 8th line of function 1, finish here, finish function 1 fully, then come back to the 6th line of int main and continue. So when I'm calling a function inside a function inside a function, a subroutine is something like a function. A routine is one program and subroutine is when you branch out of it and do another program. So that is what we mean by subroutine call and return. Every time you call a subroutine, your current location or the current instruction which you were working on should be stored. Then you branch out into that subroutine, you finish with it and you come back and resume from where you left off. So that is what it means by subroutine call and returning back to the same location. So the key idea here is when you pause something midway and leave, that location needs to be stored properly. So there are different places where you can store that return address. You can store it in the subroutine's memory. So every function has a set of memory locations allocated to it. So if I write a function called myfunc, it has an address space, meaning there is a set of memory locations which the CPU gives to that function, saying whatever variables you want to create them in this space. So when I'm doing int main and then myfunc is called, you can either put the address of the last statement in int main which you executed, the point where you currently were, you can put it in this func1's address space, because once you finish func1 you're going to come back to int main. Or you can put it in a fixed location in memory, not necessarily in that function's memory. Within your computer memory you have one register or one location which you allocate for this purpose. When I'm jumping from one function to another, I want to retain the address. For that I keep this memory location. You can fix a location like that, or in a CPU register, or in a memory stack. Memory stack, I explained this in one of yesterday's segments also. You have a bunch of registers in your CPU which work like a stack. So in the last in first out order, meaning you keep pushing values into them, they hold the value, and then when you pop, the last entered value is the first one to come out. This is the most efficient way, because this is how function inside function works, right? So we'll go back to that example, int function 1 function 2. Int main was stopped or paused at line 5. So 5 is pushed into my stack. 5, 6 are toy examples. That is not what your computer memory looks like, but this is just to give you an idea. So 5 is pushed into my stack. Then I go to function 1, I execute 7 lines and then func 2 has to be called. So func 1 is paused at 7, 7 is pushed into my stack. I go to function 2, I finish off function 2, now I want to come back to where I left. I don't know where I left, I will pop the content of that stack. So I will first get back the number 7. So I'll go to the 7th line of function 1 and I'll finish that. Again I will pop, I get 5, so I go to the 5th line of int main and I continue finishing. So when you are doing nested function calls, a stack is the easiest way to unwind them and get back to the correct location where you have to reach, which is why generally when you're doing subroutine call and return, the addresses where you are pausing are stored in a memory stack, which is a bunch of registers which act like a stack.